Hello everybody, welcome back to From Rhythm to Algorithm Part 7, the Early Universe. This episode I'm just going to talk a little bit about a couple different things, particularly the early universe. Specifically, I've now seen in the Wolfram Alpha conversation and then Alexei Filipenko something on Lex Friedman's channel again. Demonstrably either not understanding what I have presented or reacting to my language in a way that's just incorrect. So let's review the early universe. But I'm the only one that can opine on this at all. This is, the early universe is in the past. There was a definitively correct answer. And so when I first talked about this, I don't know if this was a From Rhythm to Algorithm episode or in the two videos about solving the quantum mechanics measurement problem. But remember, I'm a physical being, I use language. Physics swallows up all of language, language swallows up all of math. Those videos were proving the evolution in a reduced fashion. There's a once and for all what happened in the early universe, and frankly, is the questions you hear all the time. Is the universe infinite? How many dimensions are there? And these questions are terrible questions. Not because they're terrible questions because they are valid, but the amount of physical intuition you need to meaningfully address these is demonstrably substantial. Go watch Sean Carroll. Oh, well, no offense to any of the actual mathematicians out there. Go watch Eric Weinstein. No offense to any of the physicists out there. Go watch Lex Friedman. Oh, I'm clearly not a physicist. So like these are people that are publishing academics. Sean Carroll's an editor for Physical Review. There's plenty of other people. Those are just a handful of people I know from their YouTube channels. But anyone can ask these questions. You get a lot of intuitions. They inform your empirical value function, absolutely. But you can't access them. This is truly like the base level of physical intuition that I used to start doing these derivations back in 2016. So I've talked about stabilization events, right? We walk through, we walk through the evolution of the universe in a mathematical proof. But when Alexei and Lex are talking about shells versus points, and then what did he? He said, Alexei says something, in my opinion, I'm gonna fuck this up now. Let me pause the video. So I might as well just watch the clip. It's just, the universe is infinite. Alex Filipenko and Lex Friedman. It's just a 7-minute clip, 4-minute clip on YouTube. And so I'm just watching it right now through.
Can we talk about the Big Bang a little bit?
Sure. Yeah.
So he says Big Bang, and he's clearly talking about the beginning of the universe, which a lot of times I've heard in structured physics classes, people talk about the Big Bang as the theory of everything, and the Big Bang is specifically the early universe.
But so like the entirety of it, the universe was very small.
Right, but it was not a point.
It was not a point.
It was a point. So point is a math word. The natural definition is point, but more generally, a one-dimensional object. But remember, in the proof, this is a proof. We're saying here's a direct, definitive result. All measurements and everything Alexei's referencing is all what I called R3. And again, this is all, you have to formalize some sort of mathematics to say this to another person. This is a once and for all answer. So it is a point. Moving on.
Because if we live in what's called a closed universe now,
We do not live in a closed universe.
A three-dimensional version of that would be a hypersphere. Then regardless of how far back in...
The word universe is a specific word to everything. Anything is a given object, everything is everything that existed in the past, and everything that will exist in the future. So that's a poor Just clarifying what people mean. What's the natural definition of the word universe?
In time, you go, it was always that topological shape.
Yes, only for R3 though. Once mass starts repelling each other, has electric charge, even once radiation exists for, this is 10, again, this is 10 to the minus 36 seconds-ish of the universe. So, vibration had to stabilize into radiation. Radiation had to stabilize into mass. So he's completely correct about what he's saying for R3, which is completely incorrect for the early universe. Like the surface of a black hole is a shell, two-dimensional shell.
Point suddenly into a shell. Okay, it always had to be a shell. So when people say, well, the universe started out as a point, that's being kind of flippant.
No, wrong.
It didn't really. It just started out at a very high density, and we don't know.
Density, mass per unit area. How much mass does light have? That's what I mean by R1 in dimensional components being a word to describe something. It's not the thing it's describing. And you guys fuck this up all of the time.
Well, actually, whether it was finite or infinite, I think personally that it was finite at the time, but it expanded very, very quickly.
Okay, good. Infinity is definably local, right? That's the very beginning of the universe. Now, the word infinity has a ton of use, and it's very sloppy, right? The title of the video is "The Universe is Infinite." Just because Lex posted that, or Alexi said that, I'll say no. It's true, but, right, if we call up an alien civilization that's a galaxy away, their observable universe is different than our observable universe. That's at the galactic scale. Now, I want you to list every word you know. List every fact you know right now. You can't do it. I have infinity is definably local for all systems and sets. You can't list every word you know. You can't, even if you could call every alien that existed and learned every bit of knowledge from their entire civilization, you still wouldn't learn about everything that existed in their civilization, just in the same way you don't know about everything that's, or even kind of anything, or everything that's existed in our civilization. So infinity has a very pronounced mathematical use. And yes, the universe is probably infinite, but it's definably local. And definably local to the point where you can't, history gets a lot bigger. The basis of knowledge gets fucking immensely bigger. So you'd have to call up literally every alien civilization. And obviously those don't exist yet because the government just hasn't said, yep, they're for sure real. But this is mathematics.
But indeed, if it exponentiated...
It did exponentiate, right word.
Exponentiate, then it could in fact be infinite right now, and most cosmologists think...
It exponentiated because of the electric charge. It differentiated because of the decrease in temperature.
It is infinite.
Wait, sorry, what infinite in which dimension? Mass,
See,
size?
you see Lex picking up, or not picking up, what is infinite, what is dimension?
Space, infinite in space, and by that I mean that if you were trying
Infinite in space. Space is described with dimensionality. Directions come in pairs, forward, backwards, up and down, left and right. Which way is up? If you pointed that way, you pointed away from the gravitational field of this planet. If you're on a different planet, you might have pointed down. What's down on Earth is not down on another planet.
I'll use light to measure its size. You'd never be able to measure its size because it would always be bigger than the distance light can travel. That's what you get in a universe that's accelerating in its expansion.
Okay, but if a thing...
Yeah, you see, he doesn't even... Okay, this is what in my language series we talk about denial, and I'm going to do another episode strictly on the times I've been professionally denied scientific research, expressing scientific research. But you see Alexei Filipenko just create word salad, not know what he's talking about, and then just say, well, Lex, you don't know what you're talking about. And Lex is trying to ask a valid question. Moving on.
It's very small, not a point.
Yeah.
How can that thing be infinite?
Well, it expands exponentially. That's what the inflation theory is all.
You see, and now Alexei's just reverted his earlier point, which he said he himself says he thinks that the early universe was finite, and now he just doesn't know what he's talking about. He's responding to Lex saying, hey, "Again, this is embarrassing."
Well, indeed, at your home institution, Alan Guth is one of the originators of the whole inflationary universe idea, along with Andre Linde at Stanford University here in the Bay Area. And others, Alexei Spitz-Starobinsky and others had similar sorts of ideas. But in an exponentially expanding universe, if you actually try to make this measurement, you send light out to try to see it curve back around and hit you in the back of the head. If it's an exponentially expanding universe, the amount of space remaining to be traversed is always a bigger and bigger quantity. So you'll never get there from here.
Correct analysis, correct conclusion, kind of decent analysis.
You'll never reach the back of your head. So observationally or operationally, it can be thought of as being infinite.
That's one of the best definitions of infinity, by the way.
What's that?
No.
That's one of the best.
See, there's not the best definition of infinity. Infinity is definably local, like already done yesterday.
Sort of physical manifestations of infinity.
Yeah, because you have to ask, how would you actually measure it? Now, I sometimes say to my cosmology theoretical friends, well, if I were God and I were outside this whole thing, and I took a godlike slice in time, wouldn't it be finite no matter how big it is? And they object and they say, Alex, you can't be outside and take a godlike slice of time, you know.
Because there's nothing outside.
What the fuck is this?
Well, I'm not, you know, or also, you know, what slice of time you're taking depends on your motion, and that's true even in special relativity, that slices of time get tilted.
It's getting too sloppy for me to even give a shit. But this is what I want to emphasize on the beginning of the universe. I am personally 100,000,000% certain on the intuition that finite universe, there was a beginning, there is no end. When people say, is the universe infinite, they're asking, are sets and systems definably local? And the answer to that is definitively yes. Dimensionality, when I used it in the previous lectures, was a part of a mathematical proof. And clearly, I don't think the academic community has really digested this, right? And so, we'll find this out the next year. I don't know. Whenever the fuck you people respect the law, well, we'll see. But like I said, I can. This when I'm talking about intelligence jumps. This is 0% confusing to me. 0% opinionated. I can send it to them as clear as I can speak it to an academic, and they can't even say the argument that I derived correctly. But again, it's just true because this is how big language is. This is how the world actually works. Thanks for watching the early universe.